Today we want to talk about damping factor in EMT and RMS simulation in PowerFactory. So for this purpose, just open one of the examples in PowerFactory. Here we have the switching transient, and just open that one. And normally when you open one of the examples in PowerFactory, here you have see a lot of study cases. So here there are different scenarios. So for example, we activate overhead line uh, study case 4.2, just right click and click activate. Okay. So normally for transient analysis, we have two options, EMT and RMS simulation. If we click on the toolbox for simulation, RMS and EMT, here you have the options. And if you click on the initial calculation, here you have the option RMS and EMT simulation. So for RMS simulation, normally you will have the average value per step, and for EMT you will have the instantaneous values. So it's more for more transients. For example, for uh, switching frequency, and RMS is for more steady state phenomena. But here in the solver option, we have one option as a damping factor. So this damping factor is somehow the solver on behind of these simulations. So here, for example, you can see we selected an EMT, and the solver option by default will go for 0.99. And if we select RMS, it will change to 1. So if we change this value, sometimes you using some EMT analysis, and you will see a lot of transients, and you don't want that transients. But and also for RMS, you will not see any transients. So you need something between them. So you can play with this damping factor to reduce the transients or increase the transient that you want to see. For example, just we delete the right figure, and here we will have one figure. And for example, we only want to see phase voltage in the phase B. So for example, we can remove them, and only we have phase A value here. So for first scenario, we're using this EMT with default value of the 0.99, and we execute. So initial calculation is done, and we run the simulation, for example, for only 50 milliseconds. Then we will change the damping factor. Now is damping factor is 0.99. Then we will change the damping factor to, for example, 0.1, and we will compare how the curve will change. So this is switching phenomena in one of the transmission lines here. For example, this transmission line is open and close here. So this is for 0.99. And if you want to see another curve on this curve, here we have the result variables. So by default is all calculation. If I make another simulation, the new results will be rewrite to this one. So if you want to keep this value and add a new simulation value, just select this one, select. And here you can see in this all calculation, just copy and paste this one. So we will have all calculation one. Now we select all calculation one. So all calculation, we know it, I didn't change the name, but all calculation is for 0.99. All calculation one will be for damping factor of 0.9, for example. Execute. Run simulation again with the same value. So now we cannot see the previous one because we didn't add to the plot. So after the simulation, we'll add two plots together, and then we can compare the differences. So if I double click here we have the auto search result. So this is the last thing that we have. If I uncheck this one, and here everything will be same. If I check this one, then we can say, okay, for which plot we will use which calculation. So here I use the same one, okay, in the same phase. So for this, I use all calculation. And for this one, I use all calculation 1. Okay, so we have two of them. If I click OK, we can see all calculation was for 0.99. All calculation 1 is for 0.1. So the red one will have the red one has the lowest damping factor. The blue one has lowest damping factor. So if I zoom here, you can see the result is completely different. So we have different results. Even here, we have different results. So blue one and red. So the value are completely different. And the difference is a lot. So for example, here we have around 110 kilovolts, and here we have 100 kilovolts.